Hello. Today we're going to start the module on trees and graphs. So we're really going to focus on trees. Now, trees are inductively defined data structures. And remember what that means. What that means is that we can define a data structure in terms of some smaller versions of the same data structure. So as an example, we know that lists can be an ordered collection of elements, right? You know, that's one of the definitions, and that's one that you're familiar with. But the other one is also right here. That says that a list is either nil, right? So where nil is the empty list, right? Or it is an element, A, followed by some list. Okay, so that the way that we actually define lists is in terms of smaller lists, right? That's the way that that I want to talk about trees. Okay, so let's see. A tree is very much like a list in some ways, right? In the sense that you have some element and then it has sub-trees, okay? But the big difference between a tree and a list is right here, and that is that a tree can have 0, 1, or more trees after it. Whereas in the lists, right, we have an element, it was followed by only one list, okay? So rather than A, B, C, the way that we usually draw trees is with a picture like this. So we have A up here, we call that the root of the tree, and then we have A1 and A2, and these are children of A, okay? And A21 is a child of A2, and A11 and A2 are children of A1, okay? And then conversely, we call each node the parent of his children. So A is the parent of A1 and A2, right? So in this direction, we have parent, okay? A is the parent of A1, right? So those are the kind of terms that we use for trees.